Are you ready to dive into the world of machine learning? Today, we're going to tackle the implementation of Adagrad in Python, specifically using matrix factorization as our example. Let's get started. I completely understand how challenging it can be to implement optimization algorithms like Adagrad. Many learners face hurdles when trying to grasp the nuances of gradient descent and adaptive learning rates. You're not alone in this journey. One user recently asked, "Is my implementation of Adagrad correct for matrix factorization?" They are using Adagrad for computing gradients and want to ensure their understanding of the adaptive learning rate is spot on. Sound familiar? Let's explore this together. So what exactly is Adagrad? It's an adaptive learning rate method that adjusts the learning rate based on the historical gradients. This means that parameters with larger gradients will have their learning rates decreased, while those with smaller gradients will have theirs increased. This can lead to faster convergence in many cases. And stick around. By the end of this video, you'll not only understand how to implement Adagrad correctly, but you'll also have a solid grasp of how to troubleshoot common issues that may arise. To begin implementing Adagrad, the user should ensure they have the necessary libraries imported. This includes Adagrad for automatic differentiation and NumPy for numerical operations. Next, the user needs to create the matrix that will be decomposed. This matrix should be defined with the appropriate dimensions and data type. After creating the matrix, the user should mask one entry to simulate missing data. This is crucial for the matrix factorization process. Now, the user should define the cost function. This function will calculate the difference between the predicted matrix and the actual matrix, taking into account the masked entries. Finally, the user can implement the main Adagrad routine. This includes initializing the matrices W and H, calculating gradients, and updating the matrices using the adaptive learning rate. While your implementation seems to converge and yield reasonable solutions, it's essential to ensure that your understanding of the accumulation of gradients and the adaptive learning rate is correct. This is crucial for the effectiveness of Adagrad. A user reviewed your Adagrad implementation and noted that your code closely resembles an existing implementation found on GitHub. They pointed out that your gradient calculations and the way you adjust the learning rates match the patterns used in that reference code. They emphasized that if the reference implementation is correct, then your translation should also be correct. However, they cautioned that consensus does not guarantee correctness, but it can serve as a helpful hint. Here's a quick tip. Always visualize your cost function over iterations. This will help you understand if your model is converging properly or if adjustments are needed. And there you have it. You've learned how to implement Adagrad in Python for matrix factorization. Remember, practice makes perfect. If you found this video helpful, please subscribe for more tutorials and tips.